Lovely introduction. First of all, I'd like to thank SSTM and Hemant Tiwari ji for giving me this opportunity to share my skills and knowledge that I have gained here. And I'm sure this is a very good initiation you have started to share the knowledge among us. I really appreciate your initiative. And I would like to acknowledge the presence of Dr. Partha Parajuli sir and Dr. Padam Sai sir. I'm glad that you are here today to share my screen. Can you see my screen? Can someone unmute and just respond? Can you?
Yes, sir. Yes, sir. We can.
Okay, let me move this little bit. Here, thank you very much. Today, I'm going to talk about the road intersection design. This is the outline of my presentation. I will first try to give a just introduction about the intersection, though we all know what is road intersection and how it forms. Just I will start with the introduction, and next I will go to the types, and I will talk about how we select the proper one. This is very important. What are the different types of intersection and how we select the proper one. After that, I will try to share my experience, how normally we conduct the traffic impact study and how we decide the capacity of intersection based on the recommendation of traffic impact study. I will share some examples from Synchro. Next, I will talk about the designing of the layout plan. I'll not go in very detail, but I'll try to give some idea how normally the layout plans are designed. And I will talk about some pedestrian and cyclist consideration, what we consider while designing the an intersection, especially in the urban environment. I will try to share about the different types of software being used in this industry, and I will try to show some of the intersection design drawings from the project that I have worked on. And at the last, I would try to give some recommendation in Nepal's contest. Please, if you don't see screen or anything goes wrong, because I'm not able to interact with anyone here, I'm seeing only my screen, please interrupt and let me know. Is that okay?
Okay, sir. Okay, it's okay.
Thank you. So this is an intersection is an at-grade junction where two or more roads converge, diverge, meet, or cross. I believe we all know what is intersection. Normally, there are the points of potential vehicle conflict. This is because vehicles coming from the different road are sharing the same space on the intersection. I'm repeating it, sharing the same space at the intersections. That's why they are the point of potential vehicle conflict. Next, they are the primary bottlenecks and producing delay to the travelers. Again, what is happening? This space is being shared by the motorists of two or more different roads. So when they are sharing the same space, naturally there is a delay to the travelers, and they are creating the bottlenecks. And I would like to highlight this: the network capacity is governed by the intersection capacity, not because of the number of lanes on the road. In our country, especially in Nepal, what we see is people are talking about adding the lanes. People are ignoring intersections, and people are ignoring to design properly, operate properly of intersection, but they are talking about and they are investing money on widening the roads. In my understanding, that is very wrong, because the network capacity is governed by the intersection capacity, not because of the road capacity. Here's just I'm trying to show the different type of intersection. Coming to the selecting the proper type of intersection. Normally, the type of the intersection is depend on functional classification of the intersection roads. Functional classification means what exactly what function the road is serving. For example, that could be the expressway with with entry and with a free flow and access control. That could be the arterial road, that could be the collector road, that could be the local roads, or could be any type of roads. How the different types of roads are intersecting each other will depend what type of intersection is suitable there. This is the very basic criteria. Next, the volume and pattern of the traffic the roads are carrying. Next, the terrain and topography, and existing and planned land use. Sometimes we need to consider the planned land use, or whatever the future development around that road, whatever the future traffic that the road is going to carry, that will also govern the type of the intersection that we are going to select. Next, obviously, the capacity and safety criteria governed by the capacity of the road, capacity of the intersection, and safety. And obviously, especially the urban environment, need of the non-motorized users like pedestrian and cyclists will also govern the type of the intersections. And at the last, but not the least, for sure, cost will govern play the very big role. The key purpose of selecting the proper type of intersections are to enable the safe and efficient transfer of the traffic streams through one road to the another, as well as across the road. What is happening when the roads are intersecting to each other? Intersection will transfer traffic from one road to another road by the turning moments. We call the turning moments, and across each other when you have the straight flows. And next key purpose is providing safe passes for the all transportation modes and associated movements. Minimizing the congestion and delay for sure. That is one of the key purpose of selecting proper type. And minimizing the fuel consumption, air pollution, and noise. These are the also criteria we normally consider to choose the proper one. Here in this graph, I have taken this graph from Nepal Road Standard 2070. As per this graph, can you see this graph? As per this graph, if we have, for example, if we have traffic volume in main road crossing more than 5,000, and in the secondary road more than 500, we have to go for the grade separation as per this graph. But as per my understanding and as per my experience and as per the international standards, I think this graph is not correct. This is very important. That could be the reason we here in Nepal, people normally prefer to go in grade separated intersections. To be honest, grade separation is not required as per this graph. I am going to show another graph from the DMRB manual of UK. As per this graph, you can see that in this dark area where vehicle is around up to 12,000 AADT, annual average daily traffic, and it's around 200 in the secondary road. Even simple intersection will work. Even you can see here up to 15,000 AADT, annual average daily traffic on the main road. And you can see this large area. Can you see my mouse? This large area, up to 5,000 traffic here. It can be handled by the simple intersection with Ghost Island. And next, upper to this, you can see this another area, this big area where the traffic volume is ranging from 7,000 to here up around 18,000 AADT on the main road and secondary road. Even this much traffic can easily be handled by the channelizing the left on or right on, depending on whether we are driving on the left hand side or right hand side. If the traffic volume is beyond this space, then only we need to go for the signalized intersection here or roundabout or interchange. But I will bring back to you on the graph that is included in Nepal Road Standard 2070, where this traffic volume are very less. We can manage the traffic volume much above this figure without going to the grade separation. So I strongly recommend to look into this, the authority has to look into this and amend this graph. Next, I am going to why grade separation. Normally, people prefer to go say, okay, let's build flyover. It's like it's easy and like kind of. But before that, we need to think what we need. Do we really need free flow and access control in the system? This is very important before going for talking about grade separation. Grade separation means, by the way, it is flyover. In our countries, we normally call it flyover, where, as shown in this picture, vehicles are free to move without any obstruction in flow. You can see here in this picture down here, there are 3 layers of like flyovers. So each roads have free flow and access control. So we need to ask this control question: do we need free flow or access control on the system? Secondly, is the yard grade signalized junction running below the acceptable level of service? Then only you can think about grade separation. Did we check that it is running below the level of like service, acceptable level of service? Then the third one is, did we check that all grades, add grade options are checked and exhausted? They are not working anymore. Did we check that? This is very important because like we need to share, do we have lots of money to spend on the infrastructure without thinking much? So this is very important question. People are talking about building flyovers. It's easy to say, but they are very expensive structures. We need to have a very big foundation. There will be a lot of structural engineering work, and they are very expensive. But are they really required? Are they really serving the purpose in the urban environment? This, I believe, we need to think before going to the grade separation. Here, I'm just going to introduce the type of intersections. There are 4 types of intersections. We call them as a priority intersections, roundabouts, signalized intersection, and grade separated interchanges. When we separate the grade, we call them interchange. They are normally flyover. We call them flyover in Nepal or India. These are the various type of priority intersections. And they are normally controlled by stop and yield condition, and they are normally controlled by signing and marking only. You can see the various type of priority intersections. The first one is the normal stop condition intersection. In second here, I believe you can see my mouse. And here, this is channelized by the normal ghost line, and one storage line is created here just for the storage of this turning traffic. And this is very simple without signalizing anything. I believe I'm not able to interact anyone on the screen. I believe you are hearing me.
Yes, sir.
Yes, please continue. And this is the staggered intersection. This is again, there are channelized, and you can see my mouse, right, Hemanji? When I'm moving my mouse.
Yes, we see.
Yeah, good. Okay. So this is the like storage lane here for the turning, and this is the storage lane for the another turning. Again, without any signal, we can control the traffic flow here. Similarly, this is the typical right-in, right-out. We call it right-in, right-out in the Middle East because we follow right-hand side traffic like US, but in Nepal, it is like left-in, left-out type of intersection. These all are priority intersections. This is roundabout. We all know like what is roundabout, and but in our country, normally what I have seen is we are not designing roundabout as per the like required geometry. If you see the principle behind roundabout, they are built intentionally to create the horizontal deflection or jerk, so that they can force motorists to reduce the speed. For example, normally the basic principle, there are a lot of elements of roundabouts. I'm not going in detail, but normal principle is, can you see my mouse? Whatever the curvature is coming here, this curvature, if we extend this, it should hit the central island. Then only the roundabout will force motorists to turn like this and go. When it is forcing motorists to deflect, it will create the horizontal jerk, which will help to reduce the speed, so that the roundabout can be used by used as intersections and can be shared by the motorists from the various roads. This is the like a basic principle of roundabout design. For example, if the central island is very small here, we can see it is even in East West Highway in Nepal. In that case, what is happening? This radius is not that much, and vehicle can directly go and travel like this without any deflection. That is not serving the intended purpose of roundabout. There are the various type of, like example, this entry width here. What should be the entry width? What should be the like inscribed circle diameter? What should be the circularity roadway width? These all are depend upon the design vehicle. If you are designing for the trucks or like container carrying vehicle or very big articulated vehicle, we need this dimension bigger. If you are designing just for the car, they could be very small, like in size, and like this radius can be small. So these things are depending on the design vehicle. Anyway, I'm not going in detail on this, but we need to know the principle of roundabout, and we should know like what is the purpose of providing roundabout. Unless it is creating the horizontal deflection, it does not serve the purpose. This is the typical four-leg signalized intersection. In here, again, this is from the like standard that I have been using here in Middle East. This is based on the right-hand side driving. In our context, they will be just like slightly different because we have a like left-hand side driving here, but the principle is same. I will just give you the brief idea. Whenever this road is coming, for example, if you see my mouse here, this road is coming 2+2 lane with a median in between. When you are approaching the intersection, depending on the traffic volume, we normally create this like a right turn entry lanes separate. 2 lanes, you can see throw lanes are going towards this road. Again, we have this left turn lanes here. 2 lanes are created. Again, this is depending on the number of traffic, turning moments turning towards this road. And again, you can see here, whenever vehicle is coming from this road, hope you are seeing my mouse. When vehicle is approaching here, this is the turning moment here. Whether to put this island here or not, whether we need to design this, how many lanes we need to have in between, and how many, what should be the length of this storage length, what should be the length of acceleration and deceleration lanes. These all are depending on the design speed and the turning moments, traffic volumes. So it is very important before designing any intersection we need to go for the traffic survey. We need to have a traffic data. We need to know what is the total turning moments in each road. And based on that, we need to decide the geometrical parameters, geometrical elements. In some cases, in urban environment, we may not need this channelized island. Again, it will depend upon the like number of traffic and design speed and the intended level of service. For that, I'll talk about another software which is commonly being used to analyze the capacity of the intersection. That is called Synchro. I will give you some example there. Again, this is grade separated intersections, and as I explained earlier, this is for the free flow and access control. And if we want to introduce the free flow and access control in the system, we need to go for the grade separated interchanges. But again, is it really required to go for that? Will be governed by the traffic volume. Here I have taken this chart showing the type of intersection and road classification. Here in this column, you can see the type of the roads depending on the functional classification of this road. And here in this row, you can see the type of intersection. I'll give you the example in expressway. In expressway, we don't allow any priority intersections. We don't allow any roundabout. We don't allow any signalized intersections. If it is expressway, we go for grade separated interchanges. Because expressway are meant to have a very high speed. And if you allow this priority intersection, roundabout and signalized intersection, we cannot serve that purpose. So we have to, if it is expressway, we have to go for the grade separated interchanges. This standard are normally, this is I have copied from the Qatar Highway Design Manual, but it is based on ASTO Green Book. So this start we can find in ASTO Green Book. And again, this Qatar Highway Design Manual is referring to ASTO. And similarly, you can see here all these various type of roads and various type of intersections. And for example, I'll give you another example here in the urban environment for the local roads. If you see this local road, yes, we can have priority intersections, which can be controlled by stop and yield condition only. And we can have roundabout for sure. And we can have signalized intersection there. And we don't need separated interchange in local roads. So, and similarly for the rural environment, we have this criteria. So normally when I'm designing here, I'm just sharing my experience, we consider this chart, this Qatar Highway Design Manual as a Bible. We follow this so strictly wherever we are going to authority, like whatever we are designing, we need to get the approval from the local authorities here. To get the approval from local authorities, we are bringing Qatar Highway Design Manual, these charts with us, we take the printout, we go there and we report to them, see because of this, we are providing this. So they will check our design based on like these standards and they approve, or if they have any comment, they suggest us. This is the normal practice here. Here I am going to show the, I'm going to talk about the traffic impact study here. And I'm going to show this project. Actually, I recently completed this design project. I was working on this for one of my American client here. And this is in the northern coast of the Qatar. This is in Qatar. And my client was planning to build the petrochemical industry here. Can you see my mouse here? This is the proposed site plan. And they're planning to have a petrochemical plant here. This area, this blue hatch is around 10 kilometer square area. And you can see this in left hand side, there is a labor camp area. And to build this plant, they were planning to accommodate around 15,000 laborers here. And these laborers, during the construction period, these laborers were planned to take this route, coming to this intersection 1 and taking this Khalifa Street, you can see here, and going to this intersection B and using this intersection C, they are getting into the proposed site plan here. That was the intention. And we were asked to carry the traffic impact study for this project. So to carry the traffic, because our intersection design is depending on the traffic impact study recommendation. Whatever the volume here, ultimately, what is the type of intersection, what is the type of control you are using, these all things are depending on the traffic volume. If we don't have much traffic, we don't need to have any signalized intersection and anything. We can have just normal intersections. When the traffic volume will increase, we have to go for the channelization, we have to go for the signalization, we have to go for the maybe roundabouts, or we have to go for this maybe grade separation. These all are depending on traffic volume. So to do that, we need to know what is the existing traffic in these existing roads. This is very important. What is running now? In what is the traffic that proposed development is going to add on these roads and eventually at the intersections. This is again very important. So based on that, there are two things. One is what is the existing traffic, and another one is what is the added traffic by that proposed development. So here what we did is, this is again the site of my client's plant, petrochemical plant here, and they were planning to build this on 2021 and 2023. We just completed the design and given to them. Now they are in tendering and moving ahead. And what we did is, what I did is determine the existing traffic volume. I asked my client to carry the third-party survey. They gave us the all traffic volume on these roads, all these red marked roads. What is the existing traffic there? Second, what I did is I analyze and I find what is the site generated traffic because of this development. Site generated will come in two. One is during the construction phase, what is happening there, because we are carrying labor from the this labor camp area to the proposed site. Second, what will happen when the plant is built and normal operation is started. So I check this for the two different scenarios that I would like to share with you. And again, we forecasted for the horizon years for the traffic volume. For example, if you are operating for the 2030, what is happening? If you are operating to 2040, what is happening? If you are operating to 2050, what is happening? What will be the growth? Again, we added this growth. And we carry out the like a network and intersection modeling using software. In this chart, I'm just trying to show you what is happening in the construction phase. There are total 18,000 employees are going to, including the workers and supervisor, vendor, management team, blah, blah, they are going to work there. The total people going to that site during construction is 18,000. So to design the proper intersection, we need to have such a detailed data. Then only we can decide like what is the traffic volume being added there. And based on that, we can find what is the control type or what is the type of intersection and what kind of modification is required in existing intersection. For example, here there were 18,000 total people, people are going to work there. This is the total workforce. Out of them, like for example, management people are being carried by 55 vans, supervisor vendors are being by 18 buses, and workers are being carried by 144 buses. These are the volume added on those roads and intersections during construction phase. Similarly, this is for the operation phase. It was for the 20 years design period project. It is planned to open from 2023 to 2043. And during that time, what are the total number of people working there? What is the staffs there? Like how they will be transported there in the gate, in gate A, how many people are getting dropped here in gate B? We need to have all this data to design and decide the proper type of intersection. I'm just sharing with you how normally TIS is carried out and how normally we bring this TIS recommendation on intersection design. Now I am taking you to this. This is intersection 2. I will bring you back to this. This map here, this is the intersection 2, where this Khalifa Street and Raslafan Avenue, two major roads are intersecting here. We did the impact study for the whole network, but I'm just going to share you this intersection 2 for an example. So here, what it did is like for the operation period, for the 2026, what is happening in this intersection 2? As I explained you, we calculated the existing traffic there. We checked the existing traffic there. We added what is the extra traffic because of this development, and we just added the traffic growth for the 2016. And based on that, you can see these all turning moments. So, for example, only 4 vehicles are taking left turn here during PM peak in 2026. For example, like 636 vehicles in 1 hour are taking this right turn. Again, please remember this is right hand side driving here, so I'm sharing based on that. In our country, it is just opposite because we are like driving on left hand side there. But that will not change, and that is not changing any principle. Whatever the principle we are following there, we can like end up same there. Principally, they are same. Similarly, you can see here like 357 vehicles are taking left turn here. So what I did is I just like bring all this data in a software called Synchro, which is used for the operational analysis of the intersection. So when I added this in Synchro, then again there is one option to decide how many turning, for example, left turning lanes are required here. How many, what should be the this control type here? Do we need really channelized intersection? Do we need to allow this U-turn here? What is the functional requirement? Based on that, we can change all these parameters in Synchro, and we can check the level of service of the each lane as well as the intersection. So based on this analysis and these like a geometrical input, for example, here you can see 2 left turning lane, here you can see 2 left turning lane, here you can see 2 left turning lane, 3 through lanes are going there, 3 through lanes are going there, for example, because based on all this, we got this level of service. I will add here, synchro is optimize the flow and determine the capacity of intersections by intersection capacity utilization method as defined by Highway Capacity Manual 2010. In synchro, there is an inbuilt SCM, in fact, you can say. So based on that, it's analyzed the all flow based on the given parameter, and it gives the level of service for the each lane as well as intersection. For example, here, if you see here we are getting this level of service D. Here we are getting this level of service D. Why? You can go back to this picture. We can see because we have number of turning vehicle at 1 hour is 336. So some sort of queue will develop here. That queue will link to the delay. IO capacity manual is defining this delay and it's recommending some level of service. I'll go to that later. So for example, here you can see 357 vehicles are taking left turn here. That is the reason we need such a long storage lanes here. You can see up to here. Because there is a delay, the queue will develop. To have this queue, we need to have a long storage. Even after having this storage, we are having this B level of service. So here I'm just it's very simple, like a queue accumulation polygon. You can see here normally what is happening when signal is red, gradually this queue will develop and we'll get the maximum. There will be the maximum queue here. This is in this polygon, it is shown as a period 1. When the signal is red, queue is developed, and this is the maximum queue. Simple. When signal turn green, and all this queue will start running here. And this is period 2. From period 2 to period 30, it start free flow again. So this queue will finish at this point, and it will flow. So this is the simple queue accumulation polygon. Here at this point, I would like to show one small video just to have a look like how this operation analysis is done in synchro. Hope you are hearing me, and can you see this video? I would be happy if you can just respond me by unmuting yourself, because I'm not able to get a chance to interact with anyone.
Yes, sir.
Yes. This is basically synchro. What is happening here? We input all these data, turning moments and everything, as I shown there in my previous picture screenshot. We input there, and you can see this actually. There is a stimulation, there is a scene traffic one, what do you call this plugin is there. We can go there, click it, and you can exactly see. If you focus on this first intersection here where mouse is moving, you can see this 3 sides. It is red here, and one is yellow here, and green. The vehicle is moving. Wherever there is red, vehicle are stopping there. They are building the queue. So this is how we model this, and we check we carry out the operation analysis of the signalized intersection. I'll stop at this point. So I'll go to the next slide here. So this is all about intersections capacity analysis. Based on the recommendation of operation analysis, if it is existing intersection, we modify the geometrical elements of the intersections to achieve that capacity based on this recommendation. If, for example, intersections is working within the level of service, we leave it as it is, because this development is adding some traffic, but we don't need to change the intersection. So in report, we write this. It is modification for this intersection is not required. So I will here in this slide, I will give it quickly this control type. We can customize this in synchro. Normally, what we can do is there are 2 types of control we can have in synchro. One is traffic actuated control type. Traffic actuated means if queue is building long and it's taking time to like for the vehicle to pass and its queue is still building long, what will happen is traffic detectors will sense those queue length and they will pass the message to the traffic controller. They detect that and pass message to the controller, and that will and the controller will send message to the display to become green for little longer. Are you getting my point? There are two types. One is traffic actuated control, which you can see in the first diagram here. Second one is pre-time. For example, pre-time is if we are allowing, for example, 1 minute for one flow, after 1 minute it will turn yellow and green. But if it is traffic actuated type of control, it will sense the queue length and it will turn green till the queue ends. All the vehicle pass. So there are two types of control type. Hope it is clear. And in this diagram, I am trying to show you the coordinated signals. The coordinated signals are the type of signals where one traffic signal communicate with other one. For example, I'll give an example of Kathmandu. We have, for example, suppose we have a coordinated traffic signals in a ring road. And for example, we have a traffic signal in Chaville, next in Shukedara, for example, next in, for example, Chakrapat, we have another traffic signal, we have 3. So if vehicle is coming from in the coordinated signal type, traffic signal at Chaville can coordinate, can talk to, we can say in simple language, to the other traffic, neighboring traffic signals. It will pass the signal. So what will happen basically? All signals can turn green to clear the traffic. I'm trying to show you this time space diagram for the coordinated traffic signals. Normally, this coordinated traffic signal are well-timed coordinated system permits continuous movement along the arterial or throughout the network of the major roads. Normally, what is happening wherever we have a large volume of are carried by the arterials, we normally design with a coordinated system so that signal can communicate with each other and they can be green continuously for flow, and they can allow all the vehicle to pass. If you see this in time space diagram, you can see there, for example, in x-axis there is a time cycles and y-axis there is distance. For example, traffic signal at L distance here, when it is turning green, and when vehicle is traveling and reaching in another intersections at 2L, when the vehicle reaches there, it will again green at that time. So when it is reaching at the 2L, again it is green here. When it is reaching at another intersection, again it is green there. So what will happen? The vehicle on this direction will get a kind of free flow, because these signals are coordinated with each other. They are communicating with each other. In the same way, you can see in this time space diagram, when the vehicle is coming from intersection 4L, for example, when it is coming towards the intersection here, it's green, all green. The benefit of doing this is, normally we do this when we have intersections, signalized intersections closely spaced, and when we have major arterials or the roads, major streets which are carrying large volume. In that case, we may have to allow vehicles to move continuously. In that case, we may have to coordinate these signals. For example, in Nepal's context, in Nepal, it's very good if we can have a coordinated signals all around this ring road. If all the major intersections and ring road can communicate each other, and if they can be coordinated to each other, there will be lots of benefits. Like, for example, they will increase the network capacity, they'll increase the safety, they'll reduce the fuel consumption and improve the air quality. There are lots of benefits of coordinated systems. And this is just, I'm just trying to show this level of service, and which I was checking during that project. I'm just coming back to this project, which I was doing. For example, this intersections 2 had level of service C. At the same time, you can see this level of service C, and this is the level of service at the different AM peak and PM peak during construction and normal operation. This is based on the operational analysis from the synchro, and that we are comparing with the chart given by the highway capacity manual. And we are seeing like these are the level of service. These level of service are basically governed by the like the delay caused within 1 hour. As per the highway capacity manual, level of service of an intersection is defined based on the average stop delay. For example, average stop of the vehicle is 20 to 35 seconds in any intersections. That will give level of service C. For example, if vehicle is stopped for more than 80 seconds, average delay I'm talking about within an hour, the level of service of this intersection is F. So while designing, we normally prefer to have a level of service A, B, or in some cases C is also accepted. In my experience in Middle East, and I don't think we have any detailed guidelines in Nepal, and I think that is very important to have those guidelines. So based on this, we decide whether whatever the operational analysis we are doing, whether it is accepted or not. And normally, like whether it will be accepted by authority or not, because whatever the traffic study we are carrying, whatever the design we are doing, normally we have to go to the local authorities and get the approval on this. And as a design consultant, we have to approach them, and we need to speak based on whatever the standards are like accepted by the local authorities. Yeah, this is the normal practice here. So this is all about the operational analysis. Quickly check the timing. I think we still have around 20 minutes, right, Emanji?
Yes, sir. We can continue, sir.
We can continue, right? Okay, this is these are the like I'm just going to talk about this layout plan. And normally we consider these parameters, these elements while deciding the geometric parameter. Intersections. For example, the turning radius is depend on the sweep path of the vehicle. For example, we are, as I said earlier, if you are designing for the articulated vehicle or truck or container carrying vehicle, we need to have a very big radius. If you are designing just for the car, 6 meters is okay. So these things are depending on the design vehicle. And next criteria is visibility. I believe we all know what is the importance of visibility in intersection design, because we need to see each other, because these are the point of conflict, and unless we see other vehicles or pedestrian or cyclist, like it will be disaster. So visibility is very important in intersections. And roadway width, and if we need to have a simultaneous left turn or not. In case of Nepal, it is simultaneous right turn, whether you need to have the median U-turn or not, what are the approach lanes, storage lanes, acceleration, deceleration lane, channelizing island, taper lane. All these are the geometric parameters which normally we consider to decide the layout of an intersection. Here I'm just quickly showing this. I believe you can see this green area. This is the sweep path. Normally we check sweep path whether the vehicle can turn or not. Based on that, we decide the size of this like turnings. So, and similarly, this is the typical like T intersections. This is the intervisibility zone. You can see all these zones would be visible to each other. There should not be any obstruction. So this is again very important while designing intersections. This is the simultaneous left turn, and in our country it is simultaneous right turn. If the vehicle, if the signal is, if the intersection is signalized, sometimes we may have to allow vehicle to have simultaneous turning. For example, you can see here, vehicle can turn this side and turn this side at the same time. And again, whether we need to have a, in next diagram here, I'm showing the median U-turn. So whether we did have this U-turn or not, did you check this during the operational analysis? As per the operational analysis, if we need to have this U-turn here, so we need to provide it. To provide this, we need to maintain this geometry. I will briefly tell you, when you are providing this U-turn at the median, we need to show that whatever the vehicle is going and stopping to take the turn, when Q will build up here, that should not obstruct this flow here in the main road. For that reason only, we need to provide this storage lane here. What should be the length of this storage lane will depend on the number of vehicles taking U-turn here. That will again come from traffic counts and operational analysis of the intersection. If Q is building here, then there is a chances of a rear end collision here. Vehicle is coming at a high speed, may hit it, and it will obstruct this flow, and Q may come up in the main road here. So normally we consider these criteria. Here again, I'm trying to show this approach lanes, storage lanes, and also the taper lane at the intersection, also the deceleration lane based on this design speed. These all criteria we normally consider. I'm not going to take much time here. This is again the acceleration lane. We all know, like when you are merging the main road, vehicle has to be accelerated, and like to meet and gain that speed, we need to give some length for that. That is called acceleration length. Again, it's all depend on the operational analysis and what we want basically. And there are many cases we don't provide acceleration lane in urban area, and we can just stop this vehicle. We can design just this turning in the stop condition or ill condition. So vehicle will stop here. See, whenever it get the acceptable gap, it will go to the main. It will merge to the main road. So like we can control it that way also. Again, all these things will depend on this analysis. This is the layout plan and showing the pedestrian and cyclist consideration. What I'm trying to show is like when we have these green lines here, I'm not sure whether this diagram is very clear to you or not. This is the bike path here, this is the sidewalk here. Normally what we do at the crossing is we merge bike, cyclist and pedestrian together. And you can see my mouse here. This is the pedestrian crossing in cyclist crossing, and they can go here. If they want to go in opposite side, they can come here, they can come, and they can go like this. So this is the typical four-legged intersection considering pedestrian and cyclist criteria. So it should allow them to move there without any risk. For that purpose, we need to create some space for them, and it should be space. It should be separated either by space or time. I will come here. These are the pedestrian and cyclist consideration. Normally we consider while designing intersections. The very and first criteria we consider is separate the pedestrian or cyclist by motorized vehicle, either by time or space. We cannot mix motorized vehicle and pedestrian and cyclist without any control type. It should be either by time or space. Second criteria we consider by time means we normally provide the separate facing for the pedestrian with push button. Pedestrian can come, they can push the push button, and they can wait for the pedestrian signal to turn green, and when it is green they can turn. Or it can be merged with the main signal. For example, if some this side is red for the this approach is red for the vehicle, pedestrian can cross there. So it can be merged and combined with this main traffic signal. But in any case, whenever we have this heavy traffic flow, traffic has to be separated by time. In some cases, we may have to separate by space. In case of freeways or expressway, we don't allow vehicle to stop there, because if we stop the vehicle there, it will reduce the level of service of those roads. In that case, we may have to go for the pedestrian bridge or underpasses. That is the separation by space. Okay, so again, we need to provide the refuse island for the pedestrian. We don't expect pedestrian to cross more than 3 lanes at a time, even though it is signalized. This is the normal standard in the Middle East. maximum it is 10.95 meter pedestrian can cross even during signal. After that, it is mandatory to provide the refuge island. Refuge island is the island on the middle of the road where crossing pedestrian can cross there, and they can take a rest here, and they can see another lane, and if it is empty or the phase is green, they can again move. So this is called refuge island. And normally in the urban environment, we go for the speed calming. For that, we normally provide the speed table, speed humps, or we narrow the lanes. There are like multiple technologies developed for the speed calmings nowadays. And just to show the importance of this speed calming, I have put this graph here. In this graph, you can see in the y-axis this probability of death, and in the x-axis you can see the collision speed. For example, if a person is hit by a vehicle on like 30 km per hour, the probability of dying is around 7%. So if a pedestrian hit by a vehicle moving on, for example, this 70 km per hour, you can see probability of surviving is 7%. This region where this red line is going up exponentially, this is very important, because like we all know that like severity of injury during accidents, it nothing but the transmission of mechanical or kinetic energy in our human body. When the vehicle, when a person is hit by a very high speed, chances of like severity of the injury or chances of dying is very high, because the more this energy is transmitted its body. If the vehicle is slow, it's coming and pushing, the chances of dying is very low. So providing speed calming measure in urban environment where there is a like high pedestrian mobility, and where there is there are cyclists and other people, vulnerable road users, it is very important. I believe this one graph is more than enough to understand the importance of speed calming in urban environment. And again, this crossing lane, we don't expect pedestrian or cyclists to cross the long stretch, because they cannot do that, because there is high risk, because vehicle coming in high speed may hit them. And wherever we have like people use like disabled people who are coming in the wheelchairs, or like vision impaired people who has where blind people are moving, we normally provide this tactile payment where they can feel the pavement, and that will guide them. And for the like people using wheelchair or people carrying babies on the stroller, we provide ramps. And again, wherever we are a pedestrian crossing, we provide the bollards and railings for their safety. And if the traffic signal is signalized, we provide the separate push button for the pedestrian. If there is no push button, also it can be integrated with the main signal, and we can have a separate time separation for the pedestrian. So these are the criteria normally we consider while designing the urban intersections. I believe it is clear. I'm not able to see anyone and not able to interact with anyone. These are the softwares normally being used in this industry based on my experience. Maybe you are knowing better, but these are the software which I'm frequently using, and I'm just listing out here just to give you an idea. Civil 3D is used for the 3D modeling of the intersections, roundabout or interchanges. And MX Road is also have the same purpose to design the geometrical elements. We use this MX Road. Similarly, there is another software called InRoads. And in AutoCAD and MicroStations are the CAD platforms to work together to prepare the design drawings. And similarly, the Synchro, Zebra, Simwalk are the software used for the operational analysis of the traffic. For example, the Synchro and Zebra are used for the vehicle, and Simwalk is used for the estimation of the pedestrian, wherever what should be the width of the sidewalk. It depends on how many people are walking there. Normally standards are same. If you see in Middle East, in here, like minimum width of the sidewalk is 2 meters. as specified by the guidelines here. If we cannot meet that criteria, for example, if Qatar Highway Design Manual is specifying minimum sidewalk width 2 meters. If I cannot meet this because of some reason during designing, what I have to do is I have to request for the variation because of this reason. I'm not able to meet this criteria. I'm not able to make this 2 meters because of this reason, and I'm providing only this much. Like that, I need to write a technical note and submit it to the authority. Then only they will accept my design. If the reason is valid. That's how we are designing, and for that purpose, the importance of the design standards and guidelines is very, very important here. Here I'm going to share some design drawings that I prepare in one of my project, and this is all residential area, and these all islands are like connected by the bridges here. And this is the red mark intersection that I'm just going to show you, just to give the idea. Like I have seen a lot of fresh engineer here, and the engineer who are at the early, beginning of their career. I just want to give them an idea what kind of design drawings we are producing for intersection design. So this is the layout plan. You can see this area here. One major arterial is coming like this, and there are some small collector roads are going there. So this is basically the intersection between the arterial and collector. In this layout plan, you can see this is the arterial coming here, this is the collector here, and normally what is happening, we are considering all this pedestrian mobility here. You can see my mouse, we are providing crossings, we are providing ramps here. This is the signalized intersection. As I said here, this right turn is in yield condition, and again here there is a push button for the pedestrian. You can see the signal it is separated by time. So this is one of the safety requirement we consider here. So all these pedestrian crossing have separate phasing for the pedestrian. So this is the layout. This is I just want to include this. This is the setting out plan for the same intersection. So this is one center line going here for the collector. This is one center line coming down here for this arterial. This is the traffic signing and marking plan. Here we are showing all types of signs and markings. All these signs have individual code as per the Qatar traffic control manual. All these markings have some individual code as per this Qatar traffic signing and marking control guidelines, and based on that, based on those recommendations, we are providing all these here for the detail. And we are providing the separate details, standard details for each signs and marking. Just I wanted to give you normally what kind of drawings we are producing. This is the grading plan. You can see these contours here, what should be the cross slope here, how we are maintaining the cross slope point we are coming at the intersections, what is happening, whatever the cross slope we are using in the main roads. For example, here in here we cannot have a same cross slope here because at intersections the center of the space, this space here is being shared by the vehicle coming in the both roads. They are taking turn here and they are crossing across the intersection. So we cannot maintain this same crossfall, same slope. And on the other hand, we have to satisfy the drainage requirements. So we don't expect water to pond at intersections during rainfall. It has to be drain out quickly. So considering all these requirements, we prepare the grading plan. So this is just an example, and this is the flow-up version, and this is the main grading plan here. It looks like this, and here in the left-hand side, you can see the rig, two tables. There each points here, whatever they are turning, we are picking the northing, easting, and elevation of each point here. There are more than 50 points here in these intersections. When contractor will come for the construction, they will set out the each point based on this table at the site to build it. I am including this in this presentation because we don't go in that detail in intersection construction in Nepal. So designing properly is very important actually. So otherwise when contractor will come, when people will come at the site, they don't know how to build it. unless we give them correct information. And the area will be ponding, and there will be the pavement issue, and there the like some footpaths will be very narrow, and there is a bearing width is not constrained, standards are not followed, ramps are not properly placed, and sometimes ramps are very steep. There is no drop curve for the like for example wheelchairs and strollers, kind of this issue you can see. So if you give the clear drawing with lot of details like this, and when people are constructing, it's easy and they'll build as per this. This is the standard practice here. I just wanted to share. This is the traffic signal layout for the same signal. Let's quickly check the timing. Oh, we can go for 10 more minutes. So, record my screen. I just want to interact here. हजुर नीरज जी अझ 10 मिनेट जति ज्यादा हुन्छ नि
I think we can, sir. I think.
है ल म क्विकली सकाउन म कोसिस गर्छु है धेरै छैन अलिकति स्लाइड बाँकी छ है अब यो चाहिँ सेम दिस इज द सेम intersections like I will not take much time on these intersections and I will try to let me go here. So this is the traffic signal layout, how we are placing this this loop detector, cabling, ducting, all this detail we give in very detail. I don't know to explain much here. These are the phasings for this. Based on the synchro analysis and recommendation of synchro, we decide this, like how much it should be green for which approach and red, when, like all this. I don't go in very detailed here. So here I would like to discuss how we can improve in our contest in Nepal. I don't know what happened this. Let me. I'm not able to bring this down. How we can improve intersection in Nepal? Can you see this picture? This is the picture of Kalanki intersections. I'm just speaking this as an example because what is happening, we prepare this underpass here for the ring road. We make a big investment. We make this underpass, we build lot of this retaining walls, slab, like all the civil and structural work we did. We spent, like for example, like millions of rupees there. But this area we are keeping as it is, and still we are keeping this traffic beat here to control this traffic. We spent a lot of money to build the civil and structural things here, and this is good. It is working as an underpass, it's very good. But we hesitate to put the traffic signal here. If you see the cost of the traffic signal with compared to the civil and structural work of this intersection, it is less than 2%. So we need to think like why we are hesitating to go for to signalize these intersections and why we are still having this traffic beat here. How one or two traffic can control this haphazard flow there without any channeling. So at this point, what I would like to share is like all these enforcement that we are expecting from traffic police should be supported by engineering. Otherwise, how we can control? This is something like, you are mixing 500 gram barley and 500 gram wheat mixing together and asking someone to just separate it. It's not possible. So what is happening? The result is there is a delay in flow and there are accidents. Similarly, this is Kalanki intersections. We make it right, we pave this whole area, but we are not channelizing flow at Savili intersections. But there is no channelizing at all. Like, that's the reason what is happening there. There are few traffic police who are trying to control this, and it is very difficult for them. because engineering is not supporting at all. This is just like a big ad. Like there are a lot of conflict points. So I think our authorities and our government have to look into it. I have few recommendation for that. This is another intersection at Ring Road. You can see there are a lot, like there is no concept of storage and like acceleration, deceleration. No, that's just open at intersections. And the result we can see, it's right in front of us. I will give you a simple example here. This is the existing service road opening at the Ring Road. What is happening? This opening is just opened here. So when vehicle coming on this side have to take a U-turn here, because we are allowing this U-turn because vehicle, there is an opening here, vehicle can go there. When it is taking this U-turn here, this vehicle has to reduce the speed. When it is reducing this speed, like there is a chances of rear end collision, vehicle can hit from behind. And similarly, like everywhere intersections, we can see this type of problem. So I have some recommendation for that. This is the slide like I have got from Partha Parajuli sir, and he has identified 56 conflict point at this typical 4-leg intersection in Ring Road. And we are expecting few traffic police to control these 56 conflicting points, which is it's nearly impossible. Here, this is again the slide from Partha Parajuli sir. Maybe during like a discussion, we can discuss this. He has suggested some control type, how to channelize this, is recommending some like turning controls, storage, and like signalizing. He has like recommended some phasing for this. I'm just showing it. Maybe if we get a time, we'll discuss in discussion. During discussion, here I have some recommendation I would like to share with you all. Like for my first recommendation in a place contest is don't hesitate to adopt the new technology. I think I don't need to speak much about this. We don't have time also. My second recommendation is don't hesitate to adopt the globally proven measures on traffic management and road safety. There are standards. There are globally proven measures. To be honest, we don't have to go in very detailed, and we don't need to have very detailed. Maybe there are some things that are different than other rest of the world in our country, but around 90-95% you can adopt whatever is globally proved. So for example, I have a third recommendation. It is very important on clarity of the role and responsibility from the policy level. Like traffic management should be the engineer's responsibility. Based on my 15-16 years of experience, we cannot expect traffic police to manage the traffic because it is not their job. They don't understand what should be the storage length, what is the queue length, and what is the turning moment, what should be the acceleration, deceleration. So many parameters we discuss in this during this presentation. Traffic police, they don't know, they are not engineer. They should be separate for the enforcement, in my opinion. Like they should be given only enforcement part. For the enforcement means, for example, for the high speeding, if somebody is driving on higher speed than the posted speed, they can catch. If they are taking in the wrong way, if they are going in the one way in the opposite side, they can kind of like enforcement. But this traffic management should be the engineer's responsibility. In my another recommendation is update the Nepal standard 2070 as below, or prepare the separate design manual for the road to be used by all three governments, the central level, federal level, local levels. Nowadays, what is happening? Lots of roads are built by the municipality and the local governments, and without any proper engineering, and you can see the result during this rainy season. In fact, we can see the result throughout the year by the extent numbers, and during rainy season we can see the actual situation, what is happening there, because they don't know, like our municipality and our local government, they don't have that capability. They should be given the standards to be followed. Okay, it should be designed like this, go to the maximum gradient like this, if the soil type is like this, go for this type of retaining wall, go for this type of longitudinal gradient. Somebody has to give this standard to our local bodies or our federal government. So that is one of my recommendation, and I would like to recommend this again, this digitize the available and current right of way. In our country, what is happening, like to decide the proper intersections, we need to know the available land. If we have to go for the additional land, yes, but we need to have a clear data, what is the exact width of right of way. So for that, most of the countries, everywhere, people are digitizing this, and they have all clear CAD drawings, and in GIS they have a very good database. So I think this is very important in our country to take and go to digitize the right of way. And next one is they can establish the clear functional classification of the roads and develop the typical cross sections. For example, if it is local road, what should be the cross sections? If it is collector, like this, all typical cross sections has to be developed. So if anyone is coming in, like if any engineer is using, for example, in Danladi, some road is building, or somebody is building road in Japan, they can use that standard. So that will maintain the uniformity, and it will be easy for the engineers. So it is very important to have this, because normally all countries do have. And similarly, I would like to recommend to have a clear posted speed limit for the all kind of roads. And again, Nepal road standards will be updated, covering the needs of the urban environment, like pedestrians, cyclists, public relief requirements, etc. Again, this acceptable level of service of the road and intersections are not very clear in Nepal road standard. They have to be updated. And similarly, I have given this specific requirement on this graph shown under the section 16.2 in Nepal road standard. That traffic figure given there are very small. These all figures, whatever the Nepal road standard is suggested to go for the grade separated intersection, can be managed by simple sunlight intersections. So again, Nepal road standards should talk about the TIS requirement. If it is new development, depending on what is the traffic generated, it could be just development plan review or limited TIS or full TIS. It should be clear in the guideline. Maybe normally what is happening, like in Middle Eastern country, if you see there, they are even specifying the software. For example, all the signalized intersection has to be like analyzing the syncro, for example. So that what is happening, whatever the result is coming, they are uniform. So even in our country, if it's possible, it is very good to have like this. And again, I'd like to add here, this road safety audit has to be made mandatory in different stages. And Nepal road standard can specify those requirements. And similarly, for the traffic signal design and geometric design parameters should also be clear in guidelines. So it will be easy for everyone, whoever is using those guidelines, to implement them. And this is, again, I am just trying to put this enforcement has to be supported by design and engineering. You cannot create creating the intersections with 55 conflict points and asking traffic police to manage. This is wrong, and it has to be improved, in my opinion. Thank you very much.